Today we will talk about thermoelectricity, which is a phenomenon that appears when we make a junction of two different metals. And it can appear in two different ways. One is the Seebeck effect, which is the direct conversion of heat into electricity, and the Peltier effect, which is the conversion of electricity into heat. Let's make a demonstration. This is a junction of two different metals that is connected to the multimeter. This is a copper wire and this other one is wire from a paper clip that is covered with nickel. So it is a copper-nickel junction. I'm going to apply heat to the copper and check the voltage in the multimeter. It starts to rise as the copper heats. So we have 1 millivolt. And as the junction cools down, the voltage again starts to drop. I'm going to submerge it in water to cool it down. And you can see that we again have 0 voltage. Now I'm going to cool the copper. I'm going to apply with this can of canned air, which is not really air, it is a refrigerant. So it will cool below 0 degrees. Let's see. So you can see that now we have a negative voltage. This is a commercial Peltier unit. You can see that just by putting your finger, you generate a voltage. It is approximately 80 millivolts used by the heat of your hand. These cells are designed to work with the Peltier effect. That is, you apply a current to the cell and one side will be hot and the other will be cold. Of course, they work also in reverse with the Seebeck effect, as we just saw previously. Let's see what voltage and current can we obtain from this cell using the heat from a flame. I am using a heat sink because the greater the temperature difference between the hot and the cold side, the better the performance of the cell. I will use a piece of aluminum foil to cover the cell to prevent the direct heat from the flame. I will put the candle below the Peltier cell and let's see what voltage do we get. We got roughly 1.5 volts, or the equivalent of a battery, only with the heat of a candle. Let's now check the short circuit current. So we got a maximum of 1.5 volts and 120 milliamps. Let's see if that's enough to power this small motor that we built in a previous video. Let's open this cell to see what's inside. Each of the little squares is a bimetal junction.